Hello folks, how's it going? This is Mike Filipski coming back at you with another video on college algebra. It's late at night, we're having a good time here. In this video we are continuing our previous video when we discuss basic operations we can do with matrices. In the previous video we introduced some terminology, some notation, and we talked about how we add and subtract matrices. Very basic, very straightforward. We're going to kick off this video with scalar multiplication of constants, or of matrices. Sorry, scalar multiplication of matrices, which is taking a matrix and multiplying it by a constant. So we can take a matrix and we can multiply it by any constant whatsoever. Typically, we don't multiply it by 0 because that makes it boring, but in theory, we can. We can take a matrix and multiply it by any constant whatsoever. And this is where you'll start to see the word scalar being used, S-C-A-L-A-R. That's just a slightly more mathematical term for constant. So if you're given an m by n matrix A, we can multiply the matrix by some constant k and get the matrix Ka. And all you're doing is you're multiplying every element of that matrix by whatever your constant k was. So just as a couple of quick samples here, here's my matrix A, 2, 0, 3, negative 11, negative 1, and 8. Minus 2a, I'm just taking every entry in A and I'm multiplying it by a minus 2. So negative 4, 0, negative 6, positive 22, positive 2, negative 16. And then we can also certainly multiply it by constants that are less than 1, or fractions, or whatever. So 1/2 A, 1, 0, 3 halves, negative 11 halves, negative 1/2, and 4. So multiplying a matrix by a scalar or a constant, you just multiply every element of that matrix by that constant. Here are just some rules of how scalar multiplication and addition work with each other. If I'm going to multiply the sum of two matrices by a scalar, that's the same thing as taking the sum of each matrix multiplied by that scalar. Works the same if I'm going to multiply a matrix by the sum of two constants. That's the same thing as taking the sum of the matrix multiplied by each constant, so Ca plus DA. And then the order in which we multiply the constants doesn't matter. So C times dA is equal to CD times A. And C and D in these three examples are the constants. They are the scalars. Capital A and capital B are going to be our matrices. So we can solve basic matrix equations as if they were just typical equations that we work with every single day. Things like 2x minus 1 is equal to 13. It's really straightforward and easy to solve for x there. In that context, x is just some number. Well, we can do the same kind of thing here. We can have a sort of basic equation where we're given a matrix or two, and we are asked to solve for the variable matrix, if you will, capital X. So that's what we're going to see in this sample problem. 4x minus 2a is equal to b. So 4x minus 2a equals b implies that 4x is equal to 2a plus b. And then I can divide both sides by 4. So 2/4 a, or 1/2 a, plus 1/4 B. So let's actually write out what this matrix X is going to be. It's going to be 1/2 times our matrix 1, 2, -1, 1, 0, -3, and then plus 1/4 times 0, 4, 1, -3, 0, and -1. All right, take this 1/2, multiply it into each element of this matrix. 1/2, 1/2, 1, 0, -1/2, -3/2. Plus, I would take 1/4, multiply it into each element of this matrix. 0, -3/4, 1, 0, 1/4, -1/4. And now we're just adding these two matrices up. So 1/2 plus 0 is 1/2. 1 plus 1 is 2. -1/2 plus 1/4 is a -1/4. 1/2 plus a -3/4 is -1/4. 0 plus 0 equals 0. And then -3/2 plus a -1/4 is equal to -7/4. So there we go. This is our matrix capital X. And we just did basic mathematical operations. We moved this guy over to the other side. We multiplied both sides by 1/4, or we divided both sides by 4. And then we just made our substitutions for our matrices A and B. So solving these kinds of basic matrix equations work in exactly the same way as we solve basic linear equations, quadratic equations, anything like that. So everything up until this point, not that bad, not really that tricky, no weird calculations really that are going on here. It's a little bit of a different story when we get to multiplying two matrices. Matrix multiplication is a somewhat complicated operation. And there's a particular condition that has to hold in order for us to be able to multiply two matrices. We can find the product of the matrices A and B, and when we do that, we write the product matrix AB. We can find this product matrix AB only if the number of columns in A equals the number of rows in B. So you have your first matrix listed, you have your second matrix listed. You can only multiply the two matrices if the number of columns in the first matrix you write equals the number of rows in the second matrix that you write. And what kind of matrix do you have then when this holds and when you take the product? If A is an M by N matrix and B is an N by K matrix, then the product matrix AB is going to be an M by K matrix. So we're going to do a couple samples here. We're going to see how we multiply matrices. This is a lot easier to show as we do sample problems. I'm not necessarily going to write out a method or a process for this, so pay close focus to what I say. So here I have two matrices, A, 2, -1, 5, and 7, B, -1, 1, -3, 4, 2, 0. I want to find this product matrix A times B. Now, first thing, just to check, it's A times B first matrix listed, second matrix listed. Do the number of columns of A equal the number of rows of B? Yes, it does. 2 columns in A, 2 rows in B, we're good. So, the product matrix, AB, we're going to just set this up so far like this. Now, how do we come up with the entries in our product matrix? This is where things can get somewhat complicated here. Starting off with the entry in the first row and first column of this matrix. Before we even get to that, what's the order of this matrix that we're going to have? What size is this product matrix going to be? Well, A, we can see, has 2 rows and 2 columns, so it's a 2 by 2. B here has 2 rows and 3 columns. Using what we stated up here, the resulting product matrix is going to be a 2 by 3 matrix. These numbers there, pretend that those are sort of wiped out, and then what we have left, 2 by 3, that's going to be the size of our product matrix. So now on to actually finding the elements of our product matrix. I'm going to find the element that's in the first row and first column of this matrix. If you want the entry in the first row and first column of your product matrix, you're going to look at the first row and the first column in your 2 matrices that you're using to find your product. It's the row from the first matrix listed and the column from the second matrix listed. So I'm looking at a 2, -1, and then the -1 and 4. What I'm going to do to get the entry in the first row, first column here is I'm going to multiply the first numbers to get some product. I'm going to multiply the second numbers to get some product. And then I'm going to add those products up. This is also known as a linear combination of these values. If you've ever heard that phrase before, linear combination, we're taking products and then we're adding up those products. But I'm doing 2 times -1 plus -1 times 4. That's the entry in the first row, first column. We're going to do this same kind of thing for the other 5 entries in this matrix. Then we'll add all these things up at the end. Okay, I want the entry in the second row and first column of my product matrix. So now I'm going to look at the second row of my first matrix listed and the first column in the second matrix listed. So in the product matrix, you're thinking ith row, jth column, ith row of first matrix, jth column of second matrix. And once again, I'm going to take the product of the first guys, so in this case 5 and -1, plus the product of the second guys. 7 and 4. So that is what the entry in our second row, first column, is going to be. Let's go on to the next entry over here. This is going to be the entry in the first row, second column. So that means I want first row and now second column here. So I'm looking at 2, -1, and now 1, comma 2. So again, product of the firsts plus the product of the seconds. Switching between colors here. So 2 times 1 plus -1 times 2. When we work with the rows, we're always going from left to right. When we're working in the columns, we always go from the top down. All right, entry in second row, second column. I'm looking at second row, second column. Product of the firsts, 5 times 1, plus the product of the seconds, 7 times 2. All right, only 2 more entries to go. Next entry over here, I need the entry in first row, third column. So first row, now third column. Product of the firsts, 2 times -3, plus product of the seconds, -1 times 0. And then entry in second row, third column, second row, third column. 5 times the -3, the product of the firsts, plus product of the seconds, 7 times 0. Now let's do these products and add them up. Now that we have all of these things here, we're going to actually add these things up and find what the actual entries are, or elements are. 2 times -1 is -2. -1 times 4 is -4. -2 plus a -4 is a -6. 5 times -1 is a -5. 7 times 4 is 28. -5 plus 28 is 23. 2 times 1 is 2. -1 times 2 is -2. 2 minus 2 is 0. 5 times 1 is 5. 7 times 2 is 14. 5 plus 14 is 19. 2 times -3 is -6. -1 times 0 is 0, so that's just -6. And then 5 times -3 is -15. 7 times 0 is 0, so that gives us the -15. And this is our product matrix, AB. So very important to note how we come up with the elements in our product matrix. It's not just multiply corresponding elements, because if you tried to multiply 2 matrices that are the same order or the same size, you may not even be able to find the product matrix of those 2. That may not even be physically possible. So we're going to do one more sample here. It's going to be a bit larger, a bit more involved, a little bit uglier, I will admit, yes, but let's see. A here is a 2 by 3 matrix. B here is a 3 by 2 matrix. Do the number of columns in A equal the number of rows in B? Yes, they do. We want to find our product matrix AB, so that is possible. So just copying these things down here. 2, 3, -4, -1, 5, -1. So we know from earlier on in this video that our product matrix then should be a 2 by 2 matrix. Because again, it's like we crossed out these numbers. So let's see what we get. I want the number in my first row, first column. I need to work with the first row of the first matrix and the first column of my second matrix. Pardon me. We are going to multiply the firsts. 2 times the 2. Then we're going to add the product of the seconds. -2 times -4. And then we're going to add the product of the thirds. 1 times 5. So here we have another product and then another thing that we're adding in here. This will vary based on what are the size of your matrices and all that good stuff. All right, going down here, I want the entry in the second row, first column. So second row of first matrix, first column of the second matrix. Again, product of the firsts, 1 times 2, plus the product of the seconds, 6 times -4, plus the product of the thirds, 1 times 5 here. Okay. Next entry here, first row, second column. First row, now we're working with our second column. Product of the firsts, 2 times 3, plus product of the seconds, -2 times -1, plus product of the thirds, 1 times -1. And now entry in second row, second column, second row, second column. Product of the firsts, 1 times 3, plus the product of the seconds, 6 times -1, plus product of the thirds, 1 times another -1. It doesn't matter which element of your product matrix you find first or second or third or fourth or whatever order. The important thing is to do what we have been doing so far in this problem and the previous problem, which is keeping with that order of, okay, element in blank row, blank column, blank row, blank column. That's the main thing you have to keep to. Otherwise, The order in which you find these guys here, or the sequence in which you find these numbers here, doesn't matter. It's going to be the same matrix no matter what. Let's do some mental math now. 2 times 2 is 4. Negative 2 times negative 4 is 8. 1 times 5 is 5. 4 plus 8 plus 5 is 17. This is going to be 2. This is going to be negative 24. And this is going to be 5. So 2 plus 5 is 7. 7 minus 24 is negative 17. 6, 2, negative 1. 6 plus 2 is 8. Minus 1 is 7. And then 3, negative 6, negative 1. 3 minus 6 is negative 3. Minus 1 is negative 4. So guys, those were our 2 practice problems with multiplying matrices. These guys are sort of about middle of the road towards the more difficult end. Probably the most difficult problem I would give you to do by hand would be something where we have, say, 2 3x3 matrices, A and B here. Now, some of you may be thinking, okay, is this going to be like the system of linear equations where if you don't specify that you have to do it by hand, can I possibly do this in my calculator? Luckily, the answer is yes, you can. You can do matrix multiplication in your calculator, so I'm going to show you how that is done right now. You're going to go into that second and then x raised to the exponent of negative 1. It's all the way down here. Going to go into that guy, and you are going to enter your 2 matrices. You're going to enter one matrix in A. In the edit screen, you're going to then enter your second matrix B under B in the edit screen. I have preloaded some matrices into these 2 slots. I've made a 2x3 matrix, which has the elements 1, 2, 3, 4, 5, 6. And then the matrix B is a 3x4 matrix. The elements 1, 2, 1, 5. 4, 2, 3, negative 4, and then 1, 0, 7, 0. What the actual elements are doesn't matter. I'm more concerned about showing you how this is done. And maybe you can guess how it's done, and perhaps your guess is correct. You're just going to go into that menu. You're going to hit, when it's on the names, when names is highlighted here, you're going to hit enter on A. You're then just going to hit the typical multiplication sign that's on your calculator down here. So we see that A in brackets and then the times, and then we go back to that menu and we hit B, and then you just hit enter and you come up with your product matrix. We know that this is a product matrix because this matrix, it has 2 rows and 4 columns. And if we look at the order of each of our individual matrices, we had a 2x3 times a 3x4. So we know that that has to give us a 2x4. So that's what tells us this truly is the actual product matrix. So guys, that's how you do matrix multiplication in your calculator as well as by hand. As I said, I may specify that you have to do it by hand. If I specify that, then you have to do all this fun work here. If I don't specify, though, you have the freedom to do it in your calculator. Just be sure that you're plugging all your values in. So guys, this concludes our second video, our part 2 video of basic operations we can do with matrices. If you have any questions or comments, please be sure to reach out to me, guys. Emails, texts, voicemails, phone calls, rocks through my window, drop bombs over here, whatever you have to do. Otherwise, until the next video, take it easy, guys.